Hello everyone, welcome to new class. Today's class is about DC motor. Constructionally, there is no basic difference between DC generator and DC motor. In fact, the same DC machine can be used interchangeable as DC generator or as a motor. The principle and working of DC motor. DC motor operation is based on the principle that when a current carrying conductor is placed in a magnetic field, the conductor experiences a mechanical force, and the direction of this force is given by Fleming's left hand rule. And Fleming's left hand rule states that stretch out the left hand with first finger or the forefinger, then middle finger and the thumb at right angles to one another. If the first finger points in the direction of magnetic field, middle finger points in the direction of current, then the thumb will point in the direction of the mechanical force or motion of the conductor. So this is Fleming's left hand rule. So, and the force is given by F. Force F is equal to BIL newtons, where B is the flux density and I is the current and L is the length. And if the conductor is inclined at an angle theta to the magnetic field, then force is given by BIL sin theta newtons, where B is the flux density and I is the current through the conductor and L is the length of the conductor. Next is back EMF and its significance. When the armature of the DC motor rotate, then armature conductors move through the magnetic field and hence EMF is induced. And this induced EMF acts in opposite direction to the applied voltage V, because according to the Lenz's law, the direction of the induced EMF is such that it opposes the cause of producing it. So here the cause is the applied voltage. So this induced EMF acts in opposite direction to the applied voltage V according to Lenz's law. So this induced EMF is known as back EMF or counter EMF, EB, and EB is equal to phi ZN P divided by 60 into A, and which will be less than the applied voltage V. Consider a shunt motor. So here when DC voltage V is applied across the motor terminals, due to driving torque, the armature begins to rotate, and this rotation produces back EMF EB. The applied voltage V forces the current through the armature against the back EMF EB, and the electric work done in overcoming the power EB into IA is converted into mechanical energy and is transmitted through the shaft, and here the net voltage across the armature circuit. Net voltage across the armature circuit is V minus EB. And here the armature current IA can be written as V minus EB divided by RA, where RA is the armature resistance. And here this V, that is the applied voltage V, and armature resistance are fixed, and hence IA depends on EB. So it depends on EB, that is the back EMF, and this EB is equal to 5ZNP divided by 60 into A. So if the speed of the motor is high, then the back EMF will be high. So if the back EMF is large, then the motor will draw less armature current, and vice versa. That is, if speed is low, back EMF will be less, then IA will be more according to that. So the back EMF in a DC motor controls the armature current, and here V is equal to EB plus IA into RA. This is known as the voltage equation of the DC motor, and V into IA is EB IA plus IA square RA is known as the power equation of the DC motor. Then VIA is electric power supplied to the armature. Then EB into IA is power developed by the armature, and IA square into RA is the electric power wasted in the armature, also known as the armature copper loss. Next is necessity of motor starters. We know IA is equal to V minus EB divided by RA, and at starting, that is when the motor is stationary, there is no back EMF in the armature. So if the motor is directly switched on, the armature current IA will be equal to V divided by RA. That is, if there is no back EMF, means IA is equal to V divided by RA, and it will be very high because the armature resistance has very small value. For example, if the supply voltage V is 220 volt and armature resistance RA is equal to 1 ohm, then IA will be equal to 220 divided by 1, that is 220 amps. That is very high starting current, and this starting current may result in burning of armature due to excessive heating effect, then damaging the commutator and brushes due to heavy sparking, and excessive voltage drop in the line to which the motor is connected. In order to avoid heavy starting current, a variable resistance known as starting resistance is inserted in series with the armature circuit. So to avoid heavy starting current, a variable, so this is variable resistance, a variable resistance known as the starting resistance is inserted in series with the armature circuit, and this resistance is gradually reduced as the motor gains speed, and hence EB increases, and eventually it is cut out completely after the motor has attained full speed. So the motor starters avoid heavy starting current. Then like generators, DC motors are of three types: series wound motor, then shunt wound motor, and compound wound motors. The series motor is a variable speed motor. That is, speed is low at high torque and vice versa. However, at light or no load, the motor tends to attain dangerously high speed. So, never start a series motor on no load. The motor has high starting torque. And never start at no load. Then shunt motor, it is called constant speed motor. Constant speed motor. And here these series motors are used in electric traction, then cranes, elevators, compressors, then vacuum cleaners, etc. Then shunt motors. Shunt motors are used in lathes, then drills, then weaving machines, etc. Then compound motors. Compound motors. Differential compound motors are rarely used because of their poor torque characteristics. Then the cumulative compound motors are used fairly a constant speed is required. With irregular loads or suddenly applied heavy loads, and they are used in presses, then shears, reciprocating machines, etc. So that is about DC motors. Thank you for watching the class. If you like the classes, please like, share and subscribe my channel.